Hello viewers, in today's class we are going to solve this integral, right? So here we have to find the value of this definite integral from 0 to 1.7, and here the function is greatest integer x square, right? So let us start. So let us first call this integral as I, right? Okay, now here we can use the substitution method to evaluate this integral, right? So let us substitute t is equal to x square, right? So here we are introducing the new variable t. Now when t is equal to x square, so this means x is equal to square root of t, right? So now dt over dx is equal to 2x, and x is replaced by square root of t, so here we have 2 times square root of t. So now dx can be written as dt over 2 times of square root of t, right? Okay, now here uh, the value of x, it varies from 0 to 1.7, and when we have changed the variable from x to t, so let us change the limits accordingly, right? So when x is equal to 0, then the value of t is 0 square, that is equal to 0, and when x is equal to 1.7, the value of t is 1.7 square, that is equal to 2.89, right? So now let us rewrite this integral I as see, here the limits are from 0 to 1.7, so now the new limits are from 0 to 2.89. so here we have 0 to 2.89, and for this term we have greatest integer t, because x square is equal to t, and for dx we can write dt over 2 root t, right? So this is dt over 2 times of square root of t, right? Okay, now let us take the number line. So here we have 0, and here we have 2.89, and we see that between 0 and 2.89 we have two integers, that is 1, and here we'll have 2, right? Okay, so it means we can now split this integral I into three integrals. First is from 0 to 1, other is from 1 to 2, and the third one is from 2 to 2.89, right? So now we can write this integral I as I1 plus I2 plus I3. So now we can write I is equal to I1 is from 0 to 1, and the integrand is greatest integer t over 2 times of square root of t dt, and I2 is from 1 to 2, and we have here greatest integer t over 2 times of square root of t dt, and I3 is from 2 to 2.89, and here we have greatest integer t over 2 times of square root of t dt, right? So I is the sum of these three integrals, and now let us assign the value of this greatest integer t in these three intervals. So viewers, when t lies between 0 and 1, right? So when t lies between this interval 0 and 1, this implies that the value of greatest integer t is equal to 0 due to the definition of greatest integer function, and when t lies between 1 and 2, then the value of this greatest integer t is equal to 1, and when t lies between 2 and 2.89, then the value of this greatest integer t is equal to 2, right? So now we can take these integrals according to these values of greatest integer t. So when we take I1 from 0 to 1, then we see that the value of this greatest integer t is equal to 0, right? So here we'll have 0, and when t lies between 1 and 2, then the value of greatest integer t is 1, so here we'll have 1, right? And when the greatest integer t is 2, then t lies between 2 and 2.89, so here we'll have 2, right? So now we can rewrite these integrals as, so here the first integral is 0, and the second integral can be written as from 1 to 2, and for this we have 1, so we have 1 over 2 square root of t dt, and the third integral is from 2 to 2.89, and for this greatest integer t we have 2, so we have 2 over 2 root t dt, right? So now we can further simplify these integrals as, so now we can write this integral as half and from 1 to 2, and here we have t raised to minus half dt plus 2 and 2 get cancelled, and here we have the integral from 2 to 2.89, and here we'll have t raised to minus half dt, right? So now we can easily solve these integrals. So here we have half, and t raised to minus half is equal to t raised to half over half, and the limits are from 1 to 2, and here also the integral of t raised to minus half is t raised to half over half, and the limits are from 2 to 2.89, right? So here we have used the result that integral of x raised to n dx is equal to x raised to n plus 1 over n plus 1, right? So now here we have half and half get cancelled, and we can substitute the limits. So we have 2 raised to half minus 1 raised to half, and here 1 over 2, this 2 goes to the numerator, so here we have 2, and if we take these limits and substitute it here, we have 2.89 raised to half minus 2 raised to half, right? Okay, now this can be written as square root of 2, this is 1, and here we have 2, and the square root of 2.89 is nothing but 1.7, and here we have 1.7, this is minus square root of 2. Now we can simplify it. So this is square root of 2 minus 1, this is 2 times 1.7 is 3.4 minus, and this is 2 root 2, and now simplifying it, so square root of 2 minus 2 root 2 is minus square root of 2, and 3.4 minus 1 is 2.4, right? So we can write it as 2.4 minus square root of 2. So now 2.4 can be written as 24 over 10 minus square root of 2. So this is 12 over 5 minus square root of 2, and which can further be written as 12 minus 5 root 2 over 5, right? So the value of this integral is 12 minus 5 times square root of 2 over 5.